Hi, this is Wendy Lightheart, and today we're going to be looking at multiplying and simplifying radicals. First, we need a very important rule called the product rule for radicals. This says that if the nth root of a and the nth root of b are non-negative real numbers, then the nth root of a times the nth root of b is equal to the nth root of the product of a and b. So for example, if we wanted to multiply the square root of 13 times the square root of 5, the product rule says that we can simplify that to the square root of 13 times 5, which equals the square root of 65. Similarly, the square root of 2 times the square root of 18 becomes the square root of 2 times 18 using the product rule. And 2 times 18 is 36, and 36 is a perfect square, so we'd want to take that one step further and simplify that to a 6. Here we have a couple cube roots, so this works with any nth root as long as they're both the same root number. So in this case they're both cube roots. We can apply the product rule, and that says that if we're going to multiply these two cube roots together, we can simplify that to a single cube root of the product of 3x and 2, and that product simplifies to 6x, so our final answer would be the cube root of 6x. Now usually we use the product rule the opposite direction, and that's when we're simplifying radicals. So we would start with a single nth root, and we want to split it apart into factors where we would take the nth root of each factor of that product. And we're going to choose the factor, that product, so that a is the biggest perfect square factor of the product AB, and this helps us to simplify the radical as much as possible. So again, you're trying to think of what is the biggest perfect square factor of the product, and that's going to be your first factor. So for example, the square root of 72, if you were to list the perfect square factors starting with 4 and going up to 100, and you might want to do that for your homework, if you look down that list and see which factors are a factor of 72 and find the biggest one, you would find that 36 is the biggest perfect square factor of 72. So that's what we're going to choose to use to factor 72 into two factors, and then we split that apart using the product rule. So we'd want to square root the 36 separately, square root the 2 separately, and then those results are multiplied together, and the square root of 36 is equal to 6, so we replace the square root of 36 with the number 6, and then we also drop the multiplication symbol, because if we have a number right next to a radical, it's understood to be multiplication between them. So this would be considered completely simplified, and that's because underneath the radical we don't have any more perfect square factors, and that's what you'll end up with if you always choose to factor out the biggest perfect square factor in your first factorization. Now let's look at some more examples. So the square root of 28 we want to simplify, and it's not simplified right now because there is a perfect square that's a factor of 28, and the biggest perfect square factor of 28 is the number 4. So we'd want to factor 28 into 4 times 7, and then we can use the product rule to split that apart into the square root of 4 times the square root of 7, and the square root of 4 is equal to 2, and so we replace the square root of 4 with a 2, and then we're simplified. Now let's look at one where we have a variable to an exponent. Remember that a variable to an exponent is a perfect square if the exponent is even. So if the exponent is not even, the biggest perfect square factor is going to be the even exponent that's just less than the odd exponent that you started with. So you just subtract 1, and that will give you the biggest even number that would need to be the exponent on that x. So in this case, x to the fourth would be the biggest perfect square factor of x to the fifth, and then that leaves one more x as the other factor. Then we use the product rule that says we can square root each of these factors separately. So we square root the x to the fourth and we square root the x separately. And the square root of x to the fourth is x squared, because remember that when you take the square root of a variable to an even exponent, we just cut that exponent in half. And that would be considered completely simplified. Now let's look at an example where we have a combination of numbers and variables. So if we look at each piece one at a time, the 300 we'd want to split apart into 100 times 3, because 100 is the biggest perfect square factor of 300. Now if you look at the x to the sixth, that has an even exponent, so it's already a perfect square, so we're not going to split that apart. Then looking at the y cubed, since it's an odd exponent, we subtract 1 from that exponent, and that tells us the exponent on the biggest perfect square factor of y cubed, so that would be y squared, and the other factor would be y. Now we want to split this apart into several square roots separately, square rooting each of these factors separately using the product rule. But what we want to do is we're going to simplify the square root of each of the perfect squares, and those results will always need to be in the front or on the left side of your answer. So since multiplication can be rewritten in any order, we're going to choose to put the square root of each of the perfect squares first out front. So the square root of 100, followed by the square root of x to the sixth, followed by the square root of y squared. Those are all the biggest, or all the perfect square factors. And then we have the square root of 3 and the square root of y last. Now we need to simplify each of these radicals that can be simplified. So for example, the square root of 100 is equal to 10. The square root of x to the sixth is equal to x cubed, because again we cut the exponent in half. And the square root of y squared is y, also cutting that exponent in half. And then the square root of 3 times the square root of y. Since those are not perfect squares, we use the product rule again to combine them back under a single square root sign of the product of 3 and y. And then that would be our final answer. Here's another example where this time we have two radicals multiplied together. So the first thing we want to do is apply the product rule to combine those into a single square root, and then we multiply the 12 times 5 to get 60, and the x to the 7th times x to the 10th. Remember, you add the exponents, so that would be x to the 17th. You would do that first, and then we want to start splitting this up into perfect square factors under radicals and then the remaining factors under radicals. So for example, 60 we would split apart into 4 times 15, because 4 is the biggest perfect square factor of 60. And then x to the 17th, that's an odd exponent, so x to the 16th would be the biggest perfect square factor of x to the 17th, and we'd have one more x left over as the other factor. Now we can use the product rule and split that apart and square root the 4 and square root the x to the 16th, again doing the perfect squares first, and then times the square root of 15 times the square root of x. Now we simplify the radicals that are perfect squares. So square root of 4 is 2. The square root of x to the 16th is x to the 8th, because again we cut the exponent in half. And then the last two factors that are not perfect squares, we're going to combine those under a single square root sign and multiply the 15 and x together underneath that square root sign. And that would be our simplified answer. Here's an example with a cube root. Cube roots are worked out very similarly. We use the product rule the same way, except for we're going to be looking for perfect cube factors. So if you look at the list of perfect cubes, maybe start with 2 cubed, which is 8, and then 3 cubed, which is 27, and you probably only need to go up to about 5 cubed, which is 125. You probably won't see any examples where you need to know any bigger than that. So if you look in that list, the biggest perfect cube factor of 54 would be 27, and that's 3 cubed. So we'd split apart the 54 into 27 times 2. With the variables, with the cube root, we just need the exponent to be a multiple of 3. And since 9 is a multiple of 3, then x to the 9th is already a perfect cube, so we don't need to split that apart. So now we use the product rule to split this up and cube root all the perfect cubes first. So cube root of 27, and then the cube root of x to the 9th, and then 2, which is not a perfect cube, we would do last. And again, all these results are multiplied together. And then we simplify. So the cube root of 27 is 3, and the cube root of x to the 9th. Now, remember with the square roots, we cut the exponent in half, but with the cube roots, we divide the exponent by 3. 9 divided by 3 is 3, so we end up with x cubed when we cube root x to the 9th. And then the cube root of 2 cannot be simplified, so that just goes next. And that would be our final answer. So let's look at one more cube root. Cube root of 56 x to the 11th. So you'd want to think about what would be the biggest perfect cube factor of 56. That will be 2 cubed, which is 8. So we split apart the 56 into 8 times 7. And then x to the 11th, we want the biggest power of x that has an exponent that's a multiple of 3. So the most that we could factor out would be x to the 9th, because the next multiple of 3 is 12, and x to the 12th would be too big. So we pull out x to the 9th, and then that means that there are 2 more x's left over, because remember, 9 plus 2 would have to add up to 11, so we need to have an x squared as the other factor. Now we use the product rule to split this apart, so we cube root the perfect cubes first, so cube root of 8, and then the cube root of x to the 9th, and then we do the cube roots of the non-perfect cubes last. And then we're going to simplify each of the perfect cubes, so the cube root of 8 is 2. The cube root of x to the 9th, again we divide that exponent by 3, so we get x cubed. And the 7 and the x squared are not perfect cubes, so we just combine them using the product rule again, the other direction. Combine them into a single cube root of 7 times x squared. And that would be our final answer. So that's it for today. So hopefully you've seen enough examples of each of these types. We won't go beyond a cube root, so you won't see any 4th root or 5th root, for example, in this class. So hopefully you've seen enough examples in this video that you can get off to a good start on your homework and be ready for class tomorrow. So we'll see you then. Bye-bye.